Two conditions that a real gas behaves, and again, Silas, this is another reason we learn about it. Two conditions that a real gas behaves most, underline the word most, like an ideal gas. And again, ideal behavior, you know, if you can think of your ideal life, I mean, maybe you like your life, and that's great. I hope you do. But everyone, you know, I think would like something a little different or a little bit more, right? I wish I had more money. That would be ideal. So ideal is kind of like, you know, the perfect scenario. So how can those real gases act perfect, like a real gas, like an ideal gas should? So what do we want it to do? We want to expand it. So I'm going to leave a blank here. Blank temperature, write that down, and blank pressure. Now before you answer, or don't say it out loud, so before you answer it out loud, think in your head here. What two conditions here, temperature and pressure, are the two? But do we want to fill in the blanks with the word increase or decrease? So in other words, do we want to increase the temp and increase pressure? Do we want to increase temp and decrease pressure? Do we want to decrease and decrease? Or do we want to decrease and increase, right? So there's only 4 options.
It's multiple choice.
Sort of, but, so think. I'll give you 30 seconds to think. Remember, we want gases to expand. That's what that really means. Expand, expand, expand. So think, what do we want to do with the temperature on that gas? And what do we want to do on the pressure? And we'll introduce the next thing for a little bit before we get out of here. Raise your hand if you think you know. Go ahead.
Oh my god, why are you always calling me? Increasing, increase.
I like this one.
Decrease.
Okay, we want to increase temp. Tell us why.
Because we want it to go up.
All right, if you increase the gas or air, what does it do?
Moves faster.
It moves faster, and what else?
Hides more.
It can collide harder if it's in a sealed container, but if it's just in an
Also,
open,
the pressure goes up.
it expands. That's the point. This is the graph right here. If you heat up a gas, the volume, right, the balloon in the back before I put it in the ice bath started to expand because it was getting hot, filled with hot steam. The steam was getting hotter and hotter and hotter. So when you heat up, you still haven't seen that, Alex. I gotta show you that. So when you heat up a gas, it expands. That's what we want. Good. So now, Quinn, tell me, what's this one?
Decrease.
You want to decrease pressure. Explain.
The more pressure it means like that they're like, well, colliding and like
If we increase the pressure on a gas, what happens to the volume?
decrease.
Decreases. It's inverse. We want to do the opposite. We want to decrease, where am I? Low pressure, right? We want to decrease that pressure so we have a high volume. So basically, all you need to remember, and again, I say this a lot throughout the year, I really prefer you not to memorize it. Some kids say, oh, I'm just going to memorize increase temp, decrease pressure. Well, guess what? On the Regents, sometimes they ask the reverse. They'll say, what two conditions that are where a real gas behaves least like an ideal? So the kids who memorize it, they get all screwed up with that, right? So I prefer you to understand the concept that if you heat up a gas, particles have energy to get away from each other, so they spread out. And then if you are squeezing a gas, right? Think of a sponge. You're holding the sponge really tight. Well, when you let go, release the pressure, it expands. Same thing with the gas. It expands. So those are the two that would allow any gas up there or any gas in real life to expand. All right? That is pretty common. It's almost on at the Regents every year. Again, do I want you to get the question right? Yeah. Yes, of course. But I want you to understand the concept too. All right? So that explains those two graphs. All right. We only got a few minutes. We're going to use it. All right, picture time.
I can't draw.
Draw a mountain.
Or mountain point.
Draw a mountain.
How big is this mountain?
Like 1 page.
Like maybe like a quarter of a page, half a page. Yeah, that's my mountain. Okay. We got some snow on top, and we got the ground down here.
We got some clouds.
Actually, over here we're gonna have ocean. Oh, I didn't draw anything in the ocean this morning. We could draw like a shark fin. Shark's terrifying.
Sharknado.
Oh my gosh.
Sharks are evil. Necessary. Unnecessary evil. Alright. Sorry, I amuse myself more than I amuse anyone else. Believe me, I know this. I know this. Now, we're drawing a mountain. We need 2 people, 2 volunteers to be on the mountain. Tyler and Silas, I guess, were the first 2.
Typical.
Alright. Well, alright, who wants to be on top?
Me.
Alright, Silas is up here. Alright. Alright, got short hair, but he's got a little puff going on top there. Here's Silas.
That's
Okay.
funny.
Alright.
That's not.
Oh, wait. No, we gotta give Tyler
Tyler,
a
you got a big
visor.
head.
How do we give him a visor?
You got a big head, Tyler.
Yeah, there's your I don't know. Alright.
That's right,
There's your
Melvin.
visor, sideways and upside down. or
Tyler, you're
something.
eating my
Alright.
bird.
Okay, so we got Silas on top.
Wait, do we have to draw them?
Oh yeah.
Oh jeez.
Silas, what do you want to be holding in your hand? This morning, Reagan was holding a basketball and Nicole was holding a candle. I don't know what
I was literally just thinking.
Oh, you're recording yourself?
Yep. Don't.
Get out of our class.
Out of
Oh, you're holding her? Alright, that's a little bit.